question asks about a pretty interesting pulley system that is going on in this picture. So basically, one apartment is going down at constant velocity, while this pulley has tension that is basically equal to um, the gravitational force, or the component of it that is pulling it down. Well, at least the tension and the friction combined. And up top on here, there's another apartment where this tension from this first apartment is helping pull it up along with this little motor here. And these two things make it move up at constant velocity, meaning that there's no net force. Um, and this is going to be going against a component of gravity that's pulling this little house down, and also the component friction going against it. So the question is asking, what is the tension in this rope here, and what is the tension in the rope connected to this motor here? So here I drew some free body diagrams of the apartment on the bottom here, where there is a tension force, and there is the gravitational force, and of course the normal force. On the top apartment, there's both the tension from the pulley and the tension from the motor, while there's the force of gravitation and the normal force. And also in this one right here, there is also a force of friction going this way, F friction, because it is against the direction of movement. So three big ideas here are the ideas of inclined plane forces, which we dealt with a lot before in class, drawing free body diagrams as shown below, and finally the idea of tension and how tension provides force, basically. So to solve the problem, we have to sum the forces. So when we sum the forces, at least for the bottom one, we get 0 because there's no net acceleration. And something that's really, really important here is to identify the directions of the forces here and realize which ones are opposite to the other. So here, this is the component of gravity that's basically pulling that apartment down for the lower apartment. And this is friction that is going against kind of this movement. And of course, tension is also going against this movement. So if we do a little bit of algebra, we can actually solve for the tension value here, which comes out to be this value. And then next, we need to sum the forces for the one on top. So we do know that the tension and the tension from the motor are basically in the positive direction, which is going up. And we do know that friction and the component of gravity are directly fighting against these two tensions to kind of pull it down. So now we have 0 again because there's no net acceleration, and we can sum the forces here. And then here we solve for the value of the tension from the motor this time. Doing a little bit of algebra, we get the value of 481.4 newtons. So there are two common mistakes that I want to point out in this question. One common mistake is assuming the wrong directions on the forces. Sometimes if people mix up the signs, then they might not get the correct answer. It's really, really important to know which direction each force is pointing. Another really, really important thing in this question is assuming that the velocity is constant because it says so in the problem, and that basically means that there is no net force and no net acceleration. So those are two common mistakes that I wanted to go over. Thank you for watching the video.